quick second about autonomy versus automation and why level 5 is so hard to achieve.
I really like to think about the car, where you have an automatic gearbox, which can help you change gears, and an autonomous cars which can go with an intent. I want to go to grandmother and then perform the necessary task to do that. That is a lot harder to do, and I think that is the difference. And if we have autonomous level 5, which is you should be able to do it without any human intervention, that's very hard, because that means that the car has to find out that I want to go to grandmother. That is that's pretty tough. So of course there are gray scales in this, and I know I'm a bit arrogant when I say it, but that's where it is. So I think level 4 is a very stretched but slightly more reasonable target, where everything is autonomous. You deliver it by intent that I want to go to do a certain thing, and the machine takes over from there. But there is some human involvement in the loop every now and then to steer it by intent. That being said, level 4 is very challenging as well if you go outside a few more simple use cases.
So how do we get to level 4? If that is still a hard goal to achieve, like what are the barriers standing in the way of level 4 right now?
So we typically focus on technology, and we typically focus too much on technology. So yes, of course, you need the technology, you need the data management, you need a secure actuation, you need the security barriers, and you need artificial intelligence and connected to the right types if you want it to be agentic or not. All of that for different use cases, it makes sense, and we will provide that. The difficult part is the human in the loop, to get confidence in the algorithm that they actually deliver what they are expected, and to change the ways of working and operations and all of that. That is much harder than introducing the technology. That's at least what I think.
You got to get the people to buy into the solution before it'll work.
Yes, and trust it.
So I wanted to talk about another hot topic that is kind of a little rabbit hole that I've been diving into, and that is the edge opportunity for operators actually real? Because what I've heard is, you know, there's kind of this gap where if it's mission critical, it'll run on device, and if it's not mission critical, then you can probably afford the latency to send it to a data center. So where do operators find that use case in the sweet spot?
We hear a lot about this physical AI use cases. That means generally robots doing some of the work, robots serving the food, or robots helping the elderly to cross the roads, smart cities, etc. So that's where some of the edge AI use cases will happen. Again, when we say edge AI, we need to distinguish about different things. Is it edge AI because of latency?
Yeah.
Or is it because of security? Or is it because of regulatory requirements? So different use cases will have different characteristics. We need to be very careful about distributing too much into the RAN cell site versus keeping some of the functionality in some kind of regional data center as opposed to the public cloud. So some of the use cases requires keeping the AI inferencing on the regional data center is enough. This is where the physical AI will make a lot of progress in the inferencing, and the use cases for edge AI is more inferencing and create that user experience.
How much momentum do you see from operators behind wanting to put that compute at those edge cell sites that you're talking about?
I think the operators are evaluating. I think it is still early. We need to learn by doing some kind of evaluation and the studies and the experimentation. It's between which use cases require really cell site versus the regional site deployment.
Perfect. Thank you guys so much for your time.
Thank you.
Thank you.